Hey, it's W5HRO. Well, I went ahead, I decided to test this thing even with modulation, but I have the negative limiter unplugged just so I could kind of test it out to make sure everything was still operational. Now that I got the 807 and, 807, the 1625, that extra clamp regulation tube in there for the screen. And I'll get that circuit built when I have time, but I'm going to do the modulator down here next. But I wanted to show you that the thing is alive here. Let me. 400 watts. Yay! So everything's still working. Sorry for the video. I may not have been, because I wasn't looking at the phone the whole time. I knew I had it on the meter there a minute ago, but I just wanted to show you that it's working again, and that intermittent problem, which happened to be that big DC plate blocking cap on the tank circuit, that's what my problem was. When I put that iMac in last winter, towards the end of last winter, and I realized that was my whole problem. The power came up, everything started working. Like I said, remember, it was like a miracle. And it just, that doorknob just started leaking DC across it, and that was my problem, because my antenna, the way it is, I have a dead short to DC on my antenna. I mean, it's a short is what it is, but the RF, it's invisible, right? So anyway, I don't know if you can see, I can't really, the way I have the cables hooked up, I can't really, can we see the 807 in there maybe? Yeah, see it, well, yeah, see it's back in there, and you can see how the plate's lit up on it, see? And there's that blue, that's one of those big, what is that? That's one of those big Chinese made, but it's like one of those 40 kV .01 mics. So what I realized is these caps work fine, you just have to go bigger to handle the RF current. That's all you got to do. So let me power this thing down, and I'm going to go ahead and let's take a look at let me pull the speech amp driver rack out of there, and let's take a look at that first before. I need help getting this, somebody's going to have to help me lift this, the final 810 modulator rack out of there, because that transformer, I might be able to do it, but I've got a roll around cart thing, or not a cart, but a thing I can get it out in the garage. I just need help lifting it down on that, then lifting it up on the bench. So let's go ahead and let's take a look at the speech amp driver and the mods I'm going to make to it here now. Okay, didn't even have to blink, did we? Or did you? Out here in the garage, this is the speech amp driver rack. I built this, component per component, except for I think one minor change on one of the coupling caps for my voice after the 6SJ7. I built this from the general purpose modulator out of the Willie Moore handbook, that late 50s handbook, whichever one it was, where they had the 6B4Gs, except I used 6A3s. And let me show you what it looks like. I got the tubes pulled out of it. And this chassis, this transformer happened to meet this exact specs in that circuit, and I used to have a sticker on it, but I remember over the years it came off from being hot, and the glue, it just came off. And it was a P-some odd number. I think it's an early Hammond. I think it's a Hammond, but I'm not positive. It may be some oddball brand, but I believe it's supposed to be a 150 milliamp transformer. So here's the tubes I pulled out of it. The one here, this is what, the 6SJ7 Sylvania. These tubes are probably somewhat weak. These 6A3s, this was an oddball set that I put. One of them, I believe, was a GE, and the other one was an oddball Canadian General Electric. And these things were never balanced. I built this just to get something started, right? But I think I put this chassis together, which is why the arrangement's not exactly like I would have preferred. And I think I had something else in mind, and I wound up, when I decided I was going to build this transmitter, I decided to use this aluminum chassis since I already had it, and I already had some stuff. I think I had this mounted, couple tubes here or a couple tubes, I don't remember. Then I decided to use it, and I already had the supply filter and cap over here, mean the inductor and the choke and the cap here. So, and that's pretty lightweight. I'm going to beef all that up too. So, but what it was a 6SJ7 going right to the 6N7 phase inverter. And I had the 6A3s way over here. I should have put one here and the other one here, but I did them this way because I already had the supply mounted here because this was going to be another project originally. So that's kind of the story on that. But I had the 6SJ7 for the speech amp going to the 6N7, push-pull phase. It's a push-pull phase inverter directly coupled to the 6A3s, and the one side was always squared off really bad because it was tapping it from coming off of ground, and it needed to be done a little bit differently. But anyway. And this was the 5Y3 rectifier. And this supply, last time I hooked it up, I could have sworn when I had it going in San Jose, depending on where our line voltage was, it may have been hot when I did the measurements. That's what I don't know for sure. Here we have a stable 120 volts AC, RMS. But this supply was putting out, I think, because it's a capacitor input, because this is a dual 20 mic, and 120 is on one side and 120 is on the other. So it's a little lightweight, but I think it was idling. It was like 375, 380 volts. So just taking out this and this is one of those GT 5Y3s. This only drops like 20 some volts. The older ones would drop like 50, 60 volts. This drops like 20 some volts. That should put this supply right at, 400 volts. It's probably going to be hot by the time I get done with it, but I'm going to put 47 mics. I'm going to do something different. I'm going to beef this supply up because this is only a 450 volt cap, and this supply runs like 380X. That cap was a little bit light to begin with. So I'm going to beef up the filtering on this supply, and I may even change out the choker just a little. If I want it to the regulation to stay better, I should probably leave the choker that's a 100 mil choke. I should put 150 in there, but this one may work. I may leave it. I'll just change this. I'll just do away with this cap. Maybe I'll put the relay socket there well, you know what I was thinking though? I could put a metal relay here because I have to have a relay because what I'm going to do, well, I'll show you in a minute anyway, but what I'm saying is I'm going to convert this. Let me tell you what I'm going to do first. I'm getting ahead of myself here. What I'm going to do is the 6SJ7 is going to stay here. I'm going to rewire this socket for the 6SK7 AVC control, mainly compression with the AVC, right? My problem was I didn't have enough compression, drive keeping these A3s trying to shove the power into the A10s, and they were already having trouble the way it was. And I needed more oomph out of this, and I didn't have it. I needed compression. So what I've had to do is I've had to run the mic gain up, almost, not all the way, but like 3/4 of the way to where I get a lot of background noise, but that's the only way I could get the modulator power up high enough, and that's why I'm going to add the compression. So I'm going to have the 6SK7 there. Then this tube here, this socket's going to be changed, and that's going to be for the 6J5, driver. And I'm going to have that Hammond 124B transformer, and this is going to be rewired. Instead of using these were for two 6A3s, I'm going to have the single 6A7, which is that dual twin triode. And let me show you the circuit here. There it is. That's what I'm going to do. And I have the parts of the box in the closet there in the shack, and I'm going to bring it out here. But I'm going to pull this thing apart, and I'm going to check the voltages first. And then I'm going to, decide what I'm going to do. I already know what I'm going to do. This is what I'm going to do, but I'm just decide how I'm going to beef up the supply and see. I need to see the problem is I may wind up with more than 500 volts. I don't think so. I think I calculated it. It should be okay. Well, I need to finish calculating this, and I didn't. These should be fairly close. I don't know. This one may wind up being a lot larger in the end because I've got to drop this down to no more than 300 on the driver transformer. I don't want it. I don't want these tubes running it because right now these tubes are idling at like at 375 volts at least. They were always too hot. These need to be down at like around just below 300. You know, this one, the driver should be at 3. Then that should be 600 peak to peak, and then yeah, with the 400 volts and the negative 200 volts there going here. Yeah, see, that should be, that's the 600 volts. Yeah, that's going to do it. And that should give enough oomph to everything. Well, this is buffered anyway, because this is cathode follower buffering. So this is going to, you know, the 810 grids aren't going to load this puppy down. And this is going to act like these tubes are going to act like current amplifiers. So it's going to work good. I hope. And like I said here, I'm going to have a negative control supply. It's going to be one thing I'm going to have to do if I decide not to use this choke, you know, I'm going to have to add one more small transformer because I'm going to have to generate the voltage for this, you know, for this this control, because what I'm going to do is I'm going to, when at idle, when I'm not transmitting, I'm going to have this thing forced into like almost complete cutoff here at the grid, or maybe like really hard AVC limiting. So when I transmit, there's like, I'm going to make it to where the AVC will somehow let off of it, and it'll like have that slow release, like if I went into AVC limiting. So when I first start out transmitting, it'll be limited going in, so it won't have any audio going through the transformer till everything's already up. It'll just slowly come up. It'll come up fast, but there'll be like an instantaneous delay. There'll be an instant delay at the start when I transmit. So what I'm going to do is I'm going to have a voltage applied here or somewhere in the AVC circuit to turn it on, so it gets up through here, so it starts it in a hard AVC limiting. It just depends on how hard, right? Whether it's going to be in cutoff or just hard limiting, to where when I transmit, the relay is going to switch, and it's going to let off, or it's just going to have just the AVC control action like normal, and it's the audio level should just slowly come up within like a few milliseconds after I start transmitting. So that's sort of the plan. And I'm thinking if I put a metal cased relay here, because it's really close to this transformer, I could put that relay here, and I could mount the power transformer. I could put it right here where this choke is or something. So, but I still got to figure all this out. I'm still not quite sure how I'm going to actually convert this to this, and where I'm going to put everything and how I'm going to do it. I haven't added the relay, and that was one thing I was going to do this morning and I forgot about. I'm going to add the relay circuit. Now let me show you, when I get the 810 modulator rack out here, I'm going to have, where is it here? These pages, I just printed these out. I've got my LT Spice going again. I lost a lot of my symbols is what happened, and I'm having to recreate them. Now, see, you can see this one, right? See, I've got the new relay symbol that's in there now and everything, and I had to create a lot of the other ones that I lost, so I'm getting them back slowly but surely. They're pretty easy to create. I copy one symbol, I make a copy of it and rename it, then I just edit the symbol and I add on to delete things, move things around, and add on and do this and do that. It's pretty simple to do. That's how I did this one. So, but that's how I'm going to do I'm going to convert that desk KW bias transformer on that final 810 modulator rack, which I'm going to bring out here soon. And I'm just going to make 2 half-wave supplies, see? And then what'll happen is the 810s will have negative 200 volts. They'll have this is where the negative 200 volts is, which will also be the negative 200 volts that comes up through and connects to this and on this guy to go between these two 15K resistors here. And I do have those resistors. Where are they? I just got them the other day. I put them here somewhere, didn't I? Oh, here they are. Yeah, see, there they are. They're like the Dale Vichys. They're 25 watt 15Ks is what I got for it. That's big enough. So let me show you what I did here on this thing years ago. Because my whole idea was, excuse me, sorry for messing up the phone. I should have pulled the phone back when I did this, but I was trying to this thing's heavy. This transformer weighs a ton. So you can see what I did years ago. My idea is I saw a picture of one of the old Collins transmitters that had the vertical rack, right? That had like a vertical rack inside. I think it was like the speech amplifier, and it might have had I don't know if it had the modulator tubes, but it was at least a speech amp and driver tube rack. And I got the idea from that picture I saw, that old Collins transmitter that had this vertical rack. And the beauty is the mic jack is right here. Well, the 6SJ7's right there. How long is that piece of wire to that tube? Plus, the whole bottom of the chassis sealed off, because it's the front panel is the shield for that side of the cabinet. So this thing is completely shielded shielded all the way around. And I thought that's perfect, because my main thing was I didn't want any RF getting into the audio section. So this I thought, and I saw that old Collins design. I went perfect, and that's how I came up with this. But the modulator rack with the 810s on it, the final rack that has the the modulator transformer and that desk KW bias supply and everything that I'm going to modify, it's all on that rack. So what I did was the output of the 6A3s are actually, I'm using RCA cables to couple down to that bottom rack. And then I have the desk KW driver transformer to the 810 grids. So I had just two RCA cables, one plugs here and this plug down to that rack. I have two more RCA jacks on that rack. And then this is the, what I did was, since the power supply that powers it has to get to the one side of the driver transformer, right? Down on that final modulator rack. So I've got just one of these, this is that, the one where like your meter leads plug in, but those old Johnson. I've got the plugs, and I've got a plug, the red plug on it with the red wire, and I've got another one of these jacks on that final rack below it, that modulator rack. So that's how I get the power down to the driver transformer. So what I'm going to do is I'm going to modify this, because I have to get the 200 volts up, right, from that up to here, or I'm going to put another. Let me see how it's going to be. The other one's going to be the way with this this modification. The actual power, the voltage going down to the 810 grids is going to be coming through these RCA jacks, right? So I could just put or I could just leave them red, but I could just, if I want to change them, I can. These are better because I think these have the metal threads on them. The ones I have, that set of Johnsons I have, I think they have the black, but they're plastic though. I got to look at them. But I can change them, because what I can do is I can run that negative volts up that same line instead, just change it from the positive voltage to that negative voltage that's going to go to these 15K resistors, right? This, where is it? Yeah, this point right here, see, negative 200 volts. The 6AS7 cathode resistors. And then over here, one of these, probably both of them, I don't know why I'd done two of them, and maybe I was going to, go take this one off down to another one or something, so I put two, but this is just the PTT line, ground on transmit, and that'll also be the line I use to control the relay I'm going to add on this. So that's what I'm doing, and I got some better, these were crappy jacks. I'm surprised these never shorted out, although they're better than newer ones I've been using, but I found some much heavier, better quality ones. They've got a lot heavier plastic insulation and stuff, see? And I thought these are better quality things, and I was going to change these older ones out to these better ones, because I think the insulation around the pin with those wire solder is really thin. The black stuff, and these have thick, heavy insulation. So these would be better for this, I think. So I'm probably going to change these two out and change the one on the final relay rack, because years ago that's all I could find. Because I did all this is way before the internet, right? So it was hard to find parts you needed. Took me years, So that's what I'm doing. And I also have the new meter. The only thing is, I'm not sure how I'm going to current meter these 6A3s, or mainly the current at the 810 grids. I mean, I can set them both at minus 55 volts, but what's the current going to look like? If they're at 55, are both of them going to be the same? Probably not. So, I mean, I really don't want to drill. I'd have to get some smaller current meters, and I could put them down on the final 810 rack, or I could put them on this one. It really wouldn't matter what side. I mean, it would be better to have them right at the 810 grids, but I'm probably not going to do it. I may just put my current meter in line and adjust the current and then check the voltage. And if, you know, if they're both at 55 volts, and I'll just say, screw it. I'll just set them at 55 volts whenever I need to or something. But I'm not sure exactly. Now on this, I'm probably, this is that old design, and what's happening is from that Willie Moore handbook, that general purpose modulator, the meter's connected just like that. The center tap of the, oh no, it's the center tap of the filament transformer. I wouldn't want to use that one. I'd want to use the, I'd want to put that current meter. How am I going to get the, I'm not sure how I'm going to use it, because this was, you know, you'd adjust it for 80 mil static, right? With, this is going to be a little different. Well, because you're going to use them, you're going to adjust the current and the, you know, on the 810 grids via going through these guys. So I got to figure out exactly how I'm going to set these. I probably won't add any meters in the beginning. I'll just probably get everything working. I'll probably put my current meter in line temporarily just to set each one or something, and check the voltage. And if they're both the same, then I'll know where I need to set it. That's probably what I'll do. As long as I get the 60 mil static on the 810 modulator on the current on that, then I'm good, right? Should be. So I just don't know exactly how I'm going to meter this. I've got to take it off that filament line. And I'll probably, you know what I'll probably do? I'll probably the filament, I know what I'll do. I'll probably, because the filament line, oh, you know what? Oh no, I'm not thinking of that. That's on the final. I did one of those funky things with the modulator, that bias supply on the final modulator rack that sits below this. And I did something where the center tap is the actual power supply negative lead that's actually kept going through the tube. And okay, I remember what I did on that. But this one, no, this is a positive supply, so it's not like that. But there's a center tap that's grounded. So what I'll do is I'll just convert this meter over to the, and I'll put it in series with that center tap to ground, so I can just see so, you know, it'll tell me overall what all these are only going to draw. This will draw 10 milliamps most, 10 milliamps. This one, maybe 15, 20 at the most. And these are going to be the ones that for the current. So I'll just be able to monitor what the current is on that. That'll be fine. And then what I can do is, you know what I can do? I'll modify this old rheostat to my AVC control pot. That's what I'll do. Because I don't have the AVC, when I get this all working, but to figure out what the voltage is to start controlling this tube, then I'm gonna, you know, add the AVC circuitry in this thing, and I'll draw it back on the schematic. I'll make a revision of this with that circuitry added to it when I get it to react fast enough and just with the right amount of delay before, you know, as it slowly, you know, comes off itself. I'll add that back in there. Then I'll, you know, what was I saying? I lost my train of thought. That happens. But you get the idea, right? You know what I'm doing here. So anyway, that's the plan here. So I'm kind of tired. It's late in the afternoon now. It's early evening. It'll be dark here probably in another hour and a half. So I'm just going to wait until tomorrow. Then I'll take this thing apart. I'm going to pull the cover off this thing, and then I'll pull the panel off. And I'm going to plug it in. I want to measure some of the voltages and everything, because I forget what it's doing. I want to see if it was like 375 or 380, or if I'm remembering it incorrectly. I'm pretty sure this was a 360 transformer. And I don't mean 360 center tap. I mean so it's 360 times 2 center tap is what this was. And with the choke input, I'm getting was like, what was it, 1 point? Is choke input the same as capacitor input? I mean, well, yeah, this is what I'm saying. This is not choke input. This is capacitor input. But here now, because I'm gonna just put diodes underneath this thing. I'm removing that 5Y3, right? And like I said, I may wind up putting that relay there. If I put a metal shielded relay on there, that might be the idea. or the solution on that, like I said, but we'll see. The relay may go underneath this thing for shielding, right? But it's just going to control the supply. I mean, I have to have another transformer, so I'm going to have to find a little, I'll probably look on Hammond's website and order a little transformer I can mount on top of this thing somewhere, you know, and I'll just, you know, a small one that's, what do I need? Because see, the thing is I need around minus 35 volts at this pin. But since I'm going through this big resistor and stuff, it's going to take more, right? So I need probably a 150 volt supply at least, I would think. I'm just guessing though. I guess I should put some, I should draw this little circuit on the simulator, or just draw it up and calculate it. I like using LT Spice so I can just put a voltage on it, and I can play around, and I can quickly see what it's doing, what the currents are doing and everything. You can calculate it, but it's nice to see it on the simulator too. It's actually easier for me to do it that way. I've used that Spice program so long. I just started using it again, but I used it so many times that it's very easy for me to quickly set up a really fast test circuit using like 4 or 5 components. Bang! It's like, but in less than 10 minutes, it's all, I've already got it figured out, and I've already got everything analyzed. It's pretty fast. So anyway, I'm digressing. So let me tie the ribbons on this video tonight, and let me upload this thing, and let me do some testing, some voltage measurements, and start moving things around. Probably what I'll do is, once I figure that out, once I get this thing apart, and after I figure out all the measurements, I might do another video showing you what it used to, or maybe I'll just start modifying it. What I'll probably do is I'll probably start making the changes, and then I'll do a video then. So let me put this one online so you guys can look at it tonight and tomorrow and the next day and the next day after that. And we'll say 73s for now, but you see where this is going, right? I'm doing this old mod that this guy came up with years ago. You know, this guy here, W2ZGU. The guy was a genius. This circuit, if you read what he said about it, this was, and I said, what did I say? Did I say QST in that first video that I made of this? It's in the July 1955 issue of CQ magazine. July 55 CQ. That's where this circuit is. So read the article. It's pretty simple and straightforward. This is the solution. If you know, one of 2 things you got to do nowadays if you're building an old plate modulated transformer. I mean, a plate modulated transmitter. You either got to have, let me rephrase that. If you're going to build a transmitter, like an AM transmitter, even sideband, but just say AM out of tubes. Well, modulation iron's hard to come by nowadays. And if it's not new, what's out there, if it still works, it probably won't last too long if you really try to run a lot of power through it, right? That's the problem. So you have 2 choices. Screen modulation, which will give you the broadest audio. You can get 30, 40 kC wide audio out of a screen modulated transmitter, because you always have that limitation when you're with Class C plate modulation, when you're coupling the audio to the plate supply. Doing that, you lose frequency response. It's just a given. It's the nature of the beast, and there is no way around it. So you either got to go screen modulation, you know, or you got to do something like this, right? And this does not require a driver transformer. Now, you still have to have a modulation transformer, but what I'm getting at is that a lot of the problem is finding driver transformers for this stuff is hard to find as well. So it's a combination of both. And, you know, you could probably, if somebody did it right, probably making something really super high power might be difficult, but just say if you used a pair of 810s for cathode follower buffers, say you use some big tubes for cathode follower buffers, you could essentially modulate an RF plate supply with that if you did it correctly. You would just need to make sure you had isolation. You know, you wouldn't have the gap. And normally when a modulation transformer, it's a gap. But still, you could do it. You can modulate the base of an RF plate choke on a Class C plate modulated transmitter. If you use big enough tubes, that's why I'm saying this guy was a genius, because people could have taken this whole thing farther. So like I said, you either have screen modulation or you do plate modulation and you do something like this. With me, I knew Peter Dahl, and I had him customize that Desk KW transformer he made, and that's how I was able to do this, where I was able to get the ratio right with two tubes modulating a single one. And that's how I was able to do it. So I have the exact ratio. The problem is they did not make modulation transformers for what I'm doing. Now, if you had the old Stancore polyimpedances, yeah, you could do that. You could probably figure it out. But, it's what I'm doing special, and the ultra modulation scheme was always out there, and people did it with broadcast transmitters, but for ham radio service, people never did it because you didn't have modulation transformers to do it, and it just never caught on, just like this circuit never caught on, So anyway, here I digress. So this is about a 28-minute into the video with the first part on I'm going to add to this. So that's it for now, but you get the idea, right? You see where I'm going with this. I'm trying to build what nobody ever built and tried to get it to work correctly before, using this guy's brilliant idea to properly get enough, get the voltage to the 810s to where I don't have a problem driving them, where I don't lose a bunch of frequency response, and so on and so on, to where I've got full power, legal limit and everything, and then some if I ever need it, which I won't do that, but you know what I mean. You see what the transmitter does, right? So that's all for now. Like I said, one last time, you get the idea, right? 73s.